Okay, good afternoon. We are going to continue the repeated eigenvalue for the case of 3 by 3 system. The second example where we have two repeated eigenvalue which give only two different eigenvectors. Okay, for example, solve y prime equal to 1, 1, 1, 2, 1, negative 1, 0, negative 1, 1, y. Okay, the solution, okay, first step, we assume the solution is actually y equal to e lambda x times eigenvector v, which leads to the homogeneous system a minus lambda I v equal to 0. Where we have to determine the eigenvalue first and then the eigenvector, then we can find the solution is actually e lambda x or sometimes if the y dependent on t, so this may be e lambda t. So first of all, look back. Our A is actually this is a system, homogeneous system y prime equal to ay. So our matrix A is 3 by 3. We should have 3 eigenvalue. Okay, so first of all, we have to find A minus lambda I v. Yeah? So the A is actually, we have A is 1, 1, 1. We have 2, this is 1, negative 1, 0, negative 1, 1. Minus with lambda, I is the identity matrix. Okay. Lambda I, V is eigenvector, let's say is an element x, y, z equal to a 0 vector. So lambda multiplied with identity matrix only effects at the diagonal. Okay, and then now you can subtract 2 3 by 3 matrix. So you notice it's only taking effects at the main diagonal because the identity matrix only have value at the diagonal. That's why you have this one still 1, 1, 2. So the main diagonal here 1 minus lambda is negative 1. So 0, negative 1, 1 minus lambda. Which is this one. So we'll get here in the homogeneous system, this will be your a minus lambda I. This is a v equal to 0. Okay, we notice is only taking next changes at the main diagonal for the matrix A here. To determine the eigenvalue, we let the determinant of A minus lambda I equal to 0. Okay. Determinant of A minus lambda I equal to 0. And then to solve the determinant of 3 by 3 system, remember in the last class I said you can take any row or any column. Their sign is actually alternate. You can take any rows or any column. See which row or column consists of more 0. So in this case is column 1. So I'm going to take column 1. Column 1 we have to consider the sign is positive, negative, positive. Because you take any row or any column that consists 0, Because 0 times anything you get 0, then you have a quick case solution. So hence determinant of A minus lambda I will take first column here. So first row, first column, the sign is positive. That's why I have positive 1 minus lambda. Take this one. So you take first row, first column. So you cross it, you will left. This is determinant of 2 by 2, which is 1 minus lambda, negative 1, negative 1, 1 minus lambda. I'm going to take second row, first column. The sign is negative, so negative 2. You cross with first row, first column, second row. So left, 1, 1, negative 1, 1 minus lambda. So 1, 1, negative 1, 1 minus lambda. And the last third column, first row, is actually positive times 0. And your determinant 0 times anything will be 0. Then you just need to calculate two determinants here equal to 0. But if you want to see this one is actually this cell 0 times this determinant. You have 1, 1, 1 minus lambda, this is negative 1. Hence you simply calculate these two determinants only because this value is 0. That's why to calculate determinant of 3 by 3, we will normally prefer finding any rows or any column that consists more 0. Now you calculate determinant of 2 by 2. Remember is a main diagonal deduct with the product of the other diagonal. So you have 1 minus lambda times 1 minus lambda. So square. So minus product of the other diagonal. So this is minus positive 1. So minus 1. So minus 2. This one you have 1 times 1 minus lambda, which is 1 minus lambda. Minus product of this the other diagonal. So minus negative 1. So we have plus 1 equal to 0. And then you expand and simplify to find the cubic solution, the root of cubic equation. So when you expand it, actually this one you expand in, we have 1 minus lambda cube. So minus 1 minus lambda. So minus 2 times, when you expand inside here, 1 minus lambda minus 2 equal to 0. So total you have 1 minus lambda 1 minus lambda cube. So minus 3 times 1 minus lambda. Minus 1 minus 2 minus 3 times. So minus 2 equal to 0. And then you expand. Expand, simplify. So expand 1 minus lambda cube, you will have 1. So minus 3, you should have minus 3 lambda plus 3 lambda squared minus lambda cube. And then this is minus 3 plus 3 lambda. So minus 2 equal to 0. So negative lambda cube. And then you have here plus 3 lambda squared. So minus 3 lambda plus 3 lambda, linear term gone. So minus 3, minus 2, minus 5. 1 minus 5, we have minus 4 equal to 0. Okay, multiply by negative at both hand side, so you get lambda cube minus 3 lambda squared plus 4 equal to 0. Then you may solve it using the scientific calculator. So here in the equation modes, okay, you have polynomial of degree 3. Key in the coefficient for a polynomial of degree 3. You have here, this is 1. Quadratic term is negative 3. Linear term you don't have is 0. Constant term is 4. So you get, okay, you get 1 of the root, lambda 1 is negative 1. Lambda 2 is 2. Lambda 2 equal to 2. Okay. So against this one, like previous example also, cubic root you should have 3 cubic equation. You should have 3 roots, however the calculator only give you 2 roots. So you have to, okay, check which one is the repeated roots. Okay, from the root given by calculator, then you can write back the factor. For root is negative 1, your factor is lambda plus 1. And then root is 2, your factor will be lambda minus 2. So this one equal to 0. You want to get the constant is 4, hence, okay, 1 times negative 2 is negative 2, hence you should have negative 2. Because negative 2 times negative 2, positive 4 times 1, you get positive 4. So the repeated roots will be lambda 2 equal to 2, and then equal to lambda 3. Okay, so after, okay, then we will find the second step, finding the first eigenvector, which is v1. To find the v1 from the a minus lambda 1 I v1 equal to 0. Okay, and this is a this one is actually your a minus lambda I in general. This is v equal to 0. Okay. Replace your lambda 1, which is negative 1, into the, okay, general system a minus lambda I equal to 0. Okay, then you will have, put it, okay, lambda 1 is negative 1, so 1 minus negative 1 you have, slowly, 1 minus negative 1. This is 2, this is 0, 1. So 1 minus negative 1, negative 1, 1, negative 1. So 1 minus negative 1. Okay. That's why you have 1 minus negative 1, this 2, 2, 0. So 1, 2, negative 1, 1, negative 1, 2. And then x, y, z equal to 0. Okay. And then, okay, now, okay, like the previous example, we said if we got not easy to see whether these 3 equations are equivalent, because if we are equivalent or not, then we need to use a row operation. So easily we'll take, either you take row 2 minus row 1 or row 1 minus row 2. Then we put it, in this case I take row 1 minus row 2. Takes, okay, first row minus second row, put back into your the row 2. Because the purpose is actually we want to reduce this, and okay, a to 1 become 0. Because a31 already 0. So we take, okay, this one, subtract. First row, subtract second row. then you will get here, there's no changes on row 1 and row 3. So 2, 1, 1. So third row also no changes. So first row subtract, okay, the second row, 2 minus 2, you have 0. 1 minus 2, negative 1. 1 minus negative 1, so become 2. So now you notice, okay, 3 unknown with 3 equations. After we use the operation, second row, first row subtract first row, you get this one. So you notice row 2 and row 3 are actually equivalent, okay? Mean row 2 equivalent to row 3. Means you just reduce to, so these two rows are actually same, so you can cancel it. Hence 3 unknowns, you just left to 2 equation, which is actually first equation 2x plus y plus z equal to 0. Let me enter this space first. Okay, and second equation you have actually, this is negative y plus 2z. So negative y plus 2z equal to 0. Then from here, I will let y is equal to 2z. So let the z equal to s, hence y equal to 2s. So you plug in back, z is s, y is 2s in equation 1. So plug in z is s, y is 2s in here. So you got 2x, y is 2s, z is s equal to 0. So 2x equal to negative 3s. Then x is negative 3 over 2s. So you can have here your x, y, z. So x is negative 3 over 2. You factor out s. Z is 1s, y is 2s. Taking s equal to 1, you get the first eigenvector v1 is actually negative 3 over 2. 2, 1. So you found, okay, the first eigenvector. Okay, to eliminate the fractions, you may times, okay, to eliminate the fraction, you may times, let's say you times by 2, I can get my v1 in the integer form, so negative 3, this is 4, this is 2. Need to eliminate fraction. Okay. v1 I multiply by 2, so I get negative 3, 4, 2. So this is the first eigenvector. And then the second third step 3 finds a v2 from a minus lambda 2 I v2 equal to 0. Okay, just now we have the repeated eigenvalue is a lambda 2 equal to 2, also equal to lambda 3. So now you plug in here, plug in lambda 2 here equal to 2. So we have this one. So 1 minus 2, 2, 0. Here. This 1 minus 2, negative 1, 1, negative 1, 1 minus 2. So, so you get this one. 1 minus 2, negative 1, 1 minus 2, negative 1, 1 minus 2, negative 1. And then So against K, we notice A31 already 0. Okay, A31 already 0. We just need to eliminate A21 becomes 0 by using K-suitable row operation. Okay, notice, okay, how to make this one 0. So if row 1 you multiply by 2, you add up with row 2. And you take the operations, 2 times of row 1, okay, 2 times of row 1. So row 1 you multiply by 2, this is negative 2, this is 2, this is 2, and x, y, z equal to 0, 2, negative 1, negative 1, 0, negative 1, negative 1. Now you take the operation 2 row 1 plus row 2. Put it into row 2. Okay. So row 1 there's no changes. This operation to show to you how we multiply 2 times row 1 add up with row 2. So there's actually no changes on the row 1. Okay. No changes on row 3. So 2 times row 1 add up with row 2 here. Negative 2 plus 2 here, 0. So 2 minus 1, 1. 2 minus 1, 1. Okay. So you notice now here, actually row 2 and row 3 are equivalent. We get here, this is typed already. Then this one, you notice row 2 now equivalent to row 3. Because if row 2 you multiply by negative 1, or easy, okay, I will just do like this. If I take row 2 plus row 3, row 2 plus row 3, put it into row 3. Then you have only negative 1, 1, 1. This one x, y, z. This is 0. Mean changes on row 3. There's no changes on row 2. Row 2 add up with row 3. So 1 minus 1. 0 minus 0, 0, 1 minus, okay, add up, 1 minus 1, 0, okay, add up these two, 0. That's why what I said, okay, if actually row 3 you multiply by negative 1, you can see row 2 equivalent to row 3. Mean 3 unknown with 3 equation, we actually reduce to only 2 equation. Okay, we only reduce to 3 equation. Let me get add up at here is actually this now. Okay. Negative 1, 1, 1, 0, 1, 1, and 0, 1, 1. So 3 unknown, 3 equation reduced to only 2 equation. So you have this one. So from first equation you have actually negative x, this is plus y plus z equal to 0. From second equation here, this is y plus z. Y plus z equal to 0. So this is your equation 1, this is the equation 2. Okay, you put up y plus z equal to 0. And you substitute 2 in 1. Then here, put it here. Means negative y plus z is 0 here. That's why negative x plus 0 equal to 0 mean x equal to 0. From here we have actually x equal to 0. So from equation 2, if you let your y equal to s, hence z, because y plus z equal to 0, so z will be equal to negative s. That's why it's your xyz here. Okay, x is 0 s, y is 1x, z is negative 1s. So by taking s equal to 1, you get your v number 2 is actually 0, 1, negative 1. So this is the v2. Okay, to find so this is the v2, 0, 1, negative 1. To find v3, okay, step number 4, to find the v3, okay, you will substitute lambda 3 is actually, lambda 3 is repeated, so which is also equal to 2. So okay, you substitute into a minus 2i v3 equal to v2. Okay, a minus 2i actually you have solved here, this one. Right, a minus 2i, this part. This is a minus 2i v2 equal to 0. Right. Because the difference for repeated eigenvalue, now lambda 3 also equal to 2. So we will solve the third third eigenvector by letting a minus 2i, because this one, this part is actually a minus 2i, your v2 equal to 0. To find the for repeated eigenvalue, it's just a minus 2i v3 equal to v2. Okay, all slowly we do it. A minus 2i. Okay, there's the a. Easier, faster to copy it from here. A minus 2i, you get this one. Okay, not this one. A minus 2i, yeah, this one. After you put in, lambda is 2. After you put in lambda is 2 here. Lambda is 2. 1 minus 2. Okay, 1 minus 2, 1 minus 2. Simplify, I will get here. Yeah, copy this one. Paste here. Okay. But v3 also we let it equal to vyz, but you have to let it equal to v2. Okay, v2 that you obtain here, 0, 1, negative 1. Okay. So replace the v2 that you obtained just now, which is 0, 1, negative 1. Okay. This is a v2 that you obtained. Okay, you may take the same system from step 3 here. So, but now this is actually a minus 2i v3. v3 also that we want to find, we let it equal to x, y, z. And then now, instead of equal to 0, you equal to v2. Equal to v2, because this is repeated eigenvalue. Okay, and then using the same operation just now, which is row 1 with time 2, in 2 times row 1, add up with your row 2, put it into row 2. So there's no changes on row 1, so you just copy it down, negative 1, 1, 1. This is x, y, z. Okay, no changes on row 1. Also no changes on row 3, because row 3, a3, 1 already 0. So just copy it down, negative 1. Okay, now, 2 times row 1, 2 times row 1. Okay, we cannot see, you just put it. 2 times row 1 is here. Okay, negative 2, this is 2, this is 2. Okay, 2 times row 1 add up with row 2, which is 2, negative 1, negative 1 here. So add up these two. 2 row 1 times row plus row 2, negative 2 plus 2, 0. 2 row 1, so 2 add up with row 2, 2 minus 1 is 1. 2, okay, 2 row 2 add up with row 2, put up into row 2. So 2 minus 1 is 1. Okay, and then for right hand side also, right hand side, okay, put it here. In this value, 2 times also 0. Okay, this is 1. So negative 1. So 2 times of row 2, you still got 0. Add up with row 1, you still have 1 like this. Okay, and you can see against row 3 and row 2 are equivalent as just now. Means your row 3 equivalent to row 2. So it just left 2 equations for 3 unknowns. So we have only, okay, this one actually equivalence. So it just left 2 equations where you have here negative x plus y plus z equal to 0. Second equation is y plus z equal to 1. So plug in the y plus z equal to 1 here, in here. So you have here negative x plus 1 equal to 0. So x will be equal to 1. Okay, you get x equal to 1. And then, okay, from y plus z equal to 1, okay, for repeated eigenvalue, if just now you let y equal to s for repeated eigenvalue, then you must be consistent. You have to let your y equal to s. So, you must let y equal to s as, okay, in the previous step for the repeated eigenvalue. So if the y equal to s here, then z will be 1 minus s. Okay, so now you have already, okay, your x, y, z. X don't have s, huh? So this s. Okay, we define into a vector dependent on s and constant. X is only constant value 1. Okay, y is 1s, no constant. Okay, z is actually 1 minus 1s. Okay, and then you notice, okay, if you follow this one, same, okay, assumption with the repeated eigenvalue just now, where you let, okay, here y equal to s, then you will get the part, okay, the vector that dependent on s is actually your v2. A new constant vector is your v3. This one, this is your v2, right? So the new constant vector is your v3. So this is a, so this one, this is v3, this is the v2. Hence, okay, the general solution for your homogeneous system is actually, you have a, okay, this is a, v1 exponent lambda 1 t, where the lambda 1 is negative 1, plus your b, v2 exponent lambda 2 t, lambda 2 is 2, plus c, actually c we have repeated eigenvalue, is a v2, is a same eigenvector, you multiply by t exponent 2t plus your v3 exponent, okay, 2t, because your lambda 2 is 2. So this is similar with okay, in the case of 2 by 2, if you got repeated, repeated, so repeated at the v2, so v2 here you multiply by t, so exponent 2t, so that this term and this term won't be clash. Okay, v3 is a new eigenvector, so multiply with exponent 2t. So okay, I repeat back. So this is a case of 3 by 3 system. 3 by 3 system. However, we got 2 repeated eigenvalue, but we use only 2 different eigenvector. Mean we have a lambda 1, lambda 2 is repeated, but here for the repeated eigenvalue we can use only 1 eigenvector. Not like previous example, we got 2 repeated eigenvalue, but that 2 repeated eigenvalue we can use to 2 eigenvector. So total we got 3 eigenvector, but this case the repeated eigenvalue we can only get 1 eigenvector v2. So to get the v3, so will be you will let for the repeated, we will solve a minus lambda 3 I v3 equal to v2 to obtain the new eigenvector. And the hints, if just now when you find for v2 you let y equal to s, hence to find the v3 which is a repeated eigen k value, you must let y equal to s. So you get a vector, eigenvector which dependent on s, that will be the v2 here, and then the new constant vector is the new eigenvector v3, and hence the solution you have a v1 e lambda 1 t, lambda 1 is negative 1, b v2 exponent lambda 2 t, lambda 2 is a repeated eigenvalue, so plus c, the repeated v2 times t, exponent lambda 2t, plus the new eigenvector multiply exponent 2t. With this thank you for your attention.